All right, let's jump right in. We're going to talk about something absolutely crucial for anyone in QA today: validating your API security against the one and only OWASP's top 10. This is big, so let's get to it.
Okay, let's be real for a second. Are you still just poking around your APIs every now and then, hoping you find a security hole? You know, a little spot check here and there? Look, it's super common, but honestly, that's like trying to guard a bank by only checking the security cameras once a day. It's just not going to cut it anymore. Think about it like this. Your normal functional tests are great, right? They make sure the front door opens when someone uses the right key. Perfect. But security testing, it asks a totally different question. It asks, what if someone tries to pick the lock or, just smashes a window? That's the difference, and that's the gap we're about to close. Okay, so to beat the hackers, you got to start thinking like them. And lucky for us, we don't have to guess how they operate. We've literally been handed their playbook, the OWASP Top 10. This isn't just some boring checklist, folks. This is the script that attackers follow, and now it's yours. This right here is the main idea. We're not just running a few random security tests. We are methodically checking our API, our high-security vault, against every single known trick in the attacker's playbook. This completely changes the game. Security testing stops being a chore and becomes your secret weapon. So what exactly is this thing? Well, officially, the OWASP API Security Top 10 is the go-to guide for the biggest, baddest, and most common security risks out there for APIs. It's the industry gold standard for a reason. This is the benchmark that everyone, from tiny startups to massive corporations, uses to measure how secure they really are. And what's wild is how simple these top threats are when you break them down. Let's just look at the top 3. Number 1, BOLA is the big one. It's basically like being on your banking website and just changing the account ID in the URL to see your neighbor's balance. Yeah, it's that simple. Then there's broken authentication, which is all about tricking the login system, maybe with a token that never expires. And injection? That's about sneaking malicious commands into what looks like normal data.
All right, enough theory. Let's get our hands dirty and actually automate tests for these huge risks. And trust me, you've totally got this. Getting started is way easier than you think.
So let's start with the undisputed king of API vulnerabilities, BOLA, Broken Object Level Authorization. It's number 1 for a reason, people. Our APIs are constantly fetching things using IDs, right? Like /users, /123, /orders, /456. BOLA is what happens when the API just forgets to check if the person asking for order 456 is actually user 123. It is shockingly common, and it is incredibly dangerous.
So how do we test for this? The core idea is beautifully simple. You log in as user A, you get their token. Then you use that very same token to try and grab something that belongs to user B. The whole test comes down to a single question. Is the API smart enough to say, hey, wait a minute, user A has no business looking at user B's stuff?
And this right here, this is where your brain has to flip. In a normal test, an error is bad. But in this security test, getting a 403 forbidden error isn't a failure. It's a huge success. It means your security worked. The API saw what you were trying to do, it checked permissions, and it slammed the door shut. That is exactly what we want to see. Okay, next up, injection. This is a classic old-school attack that is still wrecking modern APIs. Basically, an attacker sends a chunk of malicious code, like a database command, but disguises it as a regular input, like a username. If your API isn't careful, it might just run that command. Whoops!
The test for this is also pretty straightforward. You use a classic, known-to-work SQL injection payload. This little string, quote, or 1 equals 1, quote, // is basically the hello world of hacking. You're trying to confuse the database. You're asking it to find a user with a blank ID or where 1 equals 1. And since 1 always equals 1, a vulnerable system might just hand over every single user it has. And again, just like our BOLA test, success here is an error. Your API should see that garbage input and just reject it. A 400 bad request is perfect. It means your API didn't even try to process it. A 403 forbidden is also great. The one thing you do not want to see is a 200 OK followed by a tidal wave of data. That's a very bad day.
So the basics seem pretty simple, right? But here's where it gets interesting, because this is where almost everyone messes up when they first get started. Let's talk about the rookie mistakes you're going to avoid. This is without a doubt the #1 rookie mistake. I'd say 90% of people miss this. The rookie just checks for
any 400-level error, but that tells you almost nothing. Did it fail because of a bad token or because of permissions? Who knows? The Pro asserts the specific error code. A 401 unauthorized means your authentication check works. A 403 forbidden means your authorization check works. See the difference? That precision is everything.
And here are a few other traps. First, only testing the happy path. Security testing is all about the unhappy path. We're looking for what breaks. Second, always check the error message itself. If your API spits back a giant stack trace, you've just handed an attacker a blueprint of your system. And finally, don't forget that tokens expire. You have to test that an old, expired token gets rejected properly.
So, you know how to avoid the common mistakes. How do you level up and become a real security champion? Let me share a few insider tips that separate the top 1% of QA engineers from everyone else. Here are the 3 steps to mastery. First, automate continuously. This stuff can't be an afterthought. It has to run in your pipeline on every single build. Second, parameterized everything. Don't just check one user against one thing. You need to systematically test every user role, admin, user, you name it, against every resource type. And third, as we just covered, assert with precision. Always validate the specific error code to prove the right security defense is working.
And really, that's the bottom line. If you can master these ideas, automating the OWASP checks, being precise, and making it part of your daily pipeline, you're not just a QA engineer anymore. You're a security champion, and you're operating at a level that puts you way ahead of the pack. So there you have it, a clear game plan for validating against the OWASP top 10. Next time, we're going to dive into another massive risk, rate limiting. We'll learn how you can stop denial of service attacks before they even have a chance to take your system offline. You won't want to miss it. See you there.